Welcome to this tutorial video on how to use the free online lifting and rigging calculator. This tool was created to provide engineers, riggers, and lifting supervisors with a reliable and user-friendly way to calculate load distribution on lifting lugs, tension on slings, and wire rope sling weight, all based on standard engineering formulas and practical rigging principles. Whether you're managing a 2-point lift, a 4-point lift, or simply estimating the weight of a wire sling, this calculator is completely free to use. In lifting operations, one of the most critical requirements is understanding how loads are distributed across all connection points. Incorrect estimations may lead to lug deformation, sling overstress, or even catastrophic lifting failure. This calculator was designed to eliminate guesswork in load distribution, provide accurate sling tension values based on sling angle, sling length differences, distance between lifting points, total lifted load, allow users to compute rigging weight, particularly for wire rope slings, which are often overlooked during lift planning. Serve as a quick reference tool during lift plan preparation. All three functions, 2-point lifting, 4-point lifting, and sling weight, are integrated into a simple interface that anyone can learn in minutes. Let's begin with the 2 lifting point calculator, which is the most common method used for lifting and rigging. This rigging calculator is not applicable for choke method and basket type rigging. Step 1. Input total load weight. Enter the weight of the object. This must include accessories such as shackles, pad eyes, and any attached equipment. Step 2. Define the horizontal distance between lifting points. The span is used to compute sling angle and vertical load path. Step 3. Enter sling lengths. If both slings are equal, the system automatically balances load distribution. If the slings have different lengths, the calculator adjusts the load to reflect realistic tension differences. Once completed inputting the data, it automatically calculates the sling angle and tension. The angle greatly influences tension. Lower angles equals higher tension. Step 5. Review the output. The results will display load at left and right lug, tension on each sling, angle factor. This helps determine whether the selected sling capacities are safe. Just do the try and input the data. Explore this calculator for free. You can access it anytime by clicking the link in the video description. The 4 lifting point calculator is essential for lifting like large platforms, skids, generators, or any equipment requiring multiple support points. Step 1. Input total load. The calculator will automatically divide the weight based on geometry, not simply by dividing by 4. Step 2. Enter lifting point coordinates or distances. This identifies the center of gravity relative to the lifting points, allowing for realistic distribution. Step 3. Enter all sling lengths. Different sling lengths cause unequal load sharing. The calculator compensates for this by applying engineering formulas on sling tension. Step 4. Observe load distribution. Output includes load at all 4 lifting lugs, sling tension on each leg, angle effects. This is the combined angle of rigging. This helps determine whether the selected sling capacities are safe. Just do the try and input the data. Explore this calculator for free. You can access it anytime by clicking the link in the video description. Rigging teams or engineer often forget to include sling weight when calculating total lift weight. This tool solves that issue. Steps. Select sling diameter. Enter sling length and sling eye length. If you're using grommet or endless sling, not required to input in sling eye length. Choose configuration, single leg, 2 leg, 4 leg. The calculator then displays weight per meter. Total sling weight. This is extremely useful for crane lifting where every kilogram matters. Take note. This is only for wire sling. Weight of the shackle, please refer to manufacturer manual. I have a previous video how to do this manual calculation, you can find in my channel. You can access it anytime by clicking the link in the video description.
Crane topple can be a catastrophic event, and it's crucial to understand the key factors behind it. Overloading, improper setup, strong winds, mechanical failures, structural deficiencies, operator errors, improper rigging, foundation issues, and environmental factors all play a role. From miscalculations to faulty components, each element can lead to disaster. By ensuring proper training, maintenance, and adherence to safety regulations, we can prevent these incidents and keep our worksite safe. Stay informed, stay vigilant, and let's work together to avoid crane collapses.
When hoisting a load, keeping the tagline rope clear of your hand is crucial. A tangled rope can lead to serious injuries if the load shifts suddenly. Think rope burns or even crushed fingers. It's all about maintaining control. A tangled rope limits your ability to guide the load, increasing the risk of it swaying or spinning. In an emergency, you need to release that rope fast. And if it's wrapped around your hand, you might not be able to. Plus, if the load pulls you off balance, you could slip or fall, especially in risky areas. And let's not forget about the safety of those around you. A swinging load can pose a danger to nearby workers. Always handle that tagline with care. Stay safe out there,